change expressed as a percent is the same thing as probably what you've heard as percent of change. You'll see this in math, you'll see it in science, you'll see it in advertising, you'll see it, for instance, my toilet paper that I just bought showed that I got 25% more for free. That is showing a percent of change. So our target is that we can find percent of change and relative error. So percent of change, it's this basic formula. It's the amount of change over the original amount. And remember that that line in the ratio, that means divide. So percent of change, it can be positive, which is showing an increase, or it can be negative, which is a decrease. So here is an example. Let's say that something was 195.5, that was the original, and it increased to 215.25. Let's pretend that this is somebody's weight. So let's see what percent of change that is in their weight. If you have ever watched The Biggest Loser, they don't declare the winner by who lost the most weight. They say who has lost the most percentage of their body weight. What was their percent of change? That is who's going to be your winner of The Biggest Loser, and here's how they find that. So remember our formula, percent of change is equal to the amount of change over divided by its original amount. So we have to plug this into the formula. To find the amount of change, we are subtracting the new amount from the original. And so 215.25 minus 195.5 divided by 195.5. 195.5 is used twice because that's the original, and in order to find the change, you have to subtract the new and the original amount. So the amount of change is 19.75. So we've subtracted to do that. It's still over 195.5. Then we divide that out, and I get 0.1010232, big long decimal, and then you can turn that into a percent. You convert the decimal to a percent and round it. So I'm going to move that decimal over 2 places. It's 10.1, and we're assuming that they want us to round to the nearest percent, which would be 10%. It is positive because the weight increased, and so it is a positive 10% change. Relative error is the ratio of the absolute value of the difference of a measured or estimated value and an actual value compared to the actual value. So it's that difference that you're comparing. So it's similar to percentage change because you're subtracting over the actual value, where with percentage change it was the original value. Those lines, if you'll recall, means absolute value, and the purpose of that is basically so that it all becomes positive. You're not going to have a positive or a negative relative error. Now, when relative error is expressed as a percent, it's called the percent error. So to kind of translate that for you, relative error is the ratio, where percent of error is that ratio as a percent. So let's say that we estimate that our school is about 45 feet tall. Your school is actually 52 feet tall. So what is the percent of error in this situation? So we're going to put it into the formula. 45, which was the estimated amount, minus the actual 52, and we're going to divide that by the actual amount. We're wanting to see how far off is our estimate from the actual amount. So 45 minus 52 is -7, and that's still in there, and the bars are there for absolute value. So don't let the whole absolute value thing confuse you. Just make it a positive. So we take the absolute value, so I'm left with 7 over 52. If I divide that out, it ends up being 0.134615, and convert that to a decimal and round it, so it gets moved over 2 spots. 13.4615 rounds to 13%.